welcome back to another session of carbon and its compound. In our previous session, we have already understood about one of the most important carbon compound, that is ethanol. In our today's session, we are going to understand about another very important carbon compound, that is ethanoic acid. But before I start my session, I would like to request you all to kindly subscribe and please share my channel among your friends and family. So let's begin today's session. Now, ethanoic acid is one of the most important carbon compound, and as its name is telling us that it is a two carbon compound. It means two carbon compound. It is a two carbon containing compound, and it is oic, that is the acid group is there. Acid group is there, or the carboxylic group is there. So its formula, molecular formula, is CH3COOH. There is a presence of 2C, that is eth, and OOH is the carboxylic acid group here. Its common name is acetic acid. A solution of 5 to 8% of acetic acid in water is popularly called as vinegar, and you all are familiar with this term vinegar. It is a very common household name which is usually used in kitchens, and the vinegar is used as a preservative mostly in pickles and in some sauces also. Now let us understand the physical properties of the ethanoic acid. Now physical properties, like in my previous session also I have told you that these are the properties which you can see or observe through your naked eyes, like color, melting point, boiling point, state, physical state, and so on. On the other hand, the chemical properties are the properties which you always see in the form of the chemical reactions. So let us start with the physical properties. First, we will see the physical state and the smell. Ethanoic acid is a colorless liquid with a very pungent smell to it. Now, the melting and the boiling points. When pure ethanoic acid is cooled, it gives us the glacier-like crystals, glacier-like big ice crystals it gives us, and therefore 100% acetic acid, which is obtained by melting these crystals, is also popularly called as glacial acetic acid. It is also called as glacial acetic acid. It boils around 391 Kelvin. Now let us see the solubility. The ethanoic acid is miscible with water in all proportions. Now let us go and see the chemical properties of the ethanoic acid. Now the first chemical property is that the acidic nature of the ethanoic acid. So if we are going to dip a blue litmus paper in the dilute solution of ethanoic acid, it will always turn to red, proving that it is acidic in nature. Okay, so here CH3COOH, and in bracket it is aqueous, means that it is diluted. So when it is mixed with little bit of water, it will release this H plus ion. This H plus ion will come out, which is here H plus aqueous plus CH3COO minus will be left. So CH3COO minus will be left. Okay, so this is basically partially ionized state. It is partially ionized state, and this ethanoic acid, it is actually a weak acid. It is a weak acid as compared to the synthetic acids like HCl or H2SO4, which gets completely ionized, or they get broken down completely in their aqueous state in H plus and Cl minus. Ethanoic acid is weak as compared to them. Now, what about the chemical reactions with the metals? So, whenever the ethanoic acid reacts with any kind of metal which are basically above hydrogen in the reactivity series, okay, it always gives us salt of that particular metal, and hydrogen gas is released. Example is written here. Ethanoic acid, when reacts with sodium, it gives you sodium ethanoate. Okay, this sodium Na, sodium ethanoate. There are 2C ethane and it is O8 plus H2. You can simply write sodium salt also, that is also correct. If you cannot remember this name, you can simply write sodium salt. Sodium salt. Okay. Now similarly, if ethanoic acid is made to react with calcium, then again it will form calcium ethanoate along with evolution of hydrogen gas. Here also hydrogen gas will be evolved. So here it is calcium ethanoate. You can simply write calcium salt. Okay. Now here you are seeing that it is whole twice. CH3COO whole twice Ca. It is why? Because calcium is having a valency of 2. Calcium valency is 2. Okay. On the other hand, CH3COO valency is 1. So it is CH3COO whole twice Ca. Clear? So reaction with active metals like those which are highly reactive, sodium, potassium, calcium, magnesium, aluminium, iron, zinc, etc., which lie above hydrogen in the reactivity or in the activity series, they react with ethanoic acid, evolving hydrogen gas and forming the metal salt. So if it is reacting with potassium, it will form potassium salt of it. If it is reacting with Mg, that is magnesium, it will form magnesium salt of it. Okay, like 2 examples I have explained you about the sodium and calcium here. Now let us see more properties of the ethanoic acid. The next important property of ethanoic acid with alkalis or the bases. Okay, so whenever ethanoic acid reacts with any kind of alkali, okay, it always forms the salt, the metal salt, plus it gives out water. Okay, so here in this reaction, this is wrongly typed actually. It should be water here, H2O. So whenever ethanoic acid reacts with a base like sodium hydroxide, it gives sodium salt, okay, and water. Now this is the formula of the ethanoic acid, and this is sodium hydroxide, one of the alkalis or the bases. So here what will happen then, when they both will react, this H will come out. H plus will come out and this will become negative. CH3COO minus will become negative. This Na will come out from the sodium hydroxide and it will attach here. So you will get CH3COO Na, and this H will combine with OH and it will form water. This reaction can be also written with potassium hydroxide, CH3COOH plus KOH. So what will happen? This H will be combining with OH, okay, and this K will be combining with CH3COO. So here it will be CH3COO-K plus H2O. Okay, so in this manner it will become the potassium salt of it. And here it is sodium salt, or you can simply write its name, the sodium ethanoate. Now this reaction is, if you see, this is acid side, this is base side. This is the acid side and this is the base side. So this we have already understood in the previous chapters and in our previous classes, that whenever an acid reacts with a base, that particular reaction is called as neutralization reaction. So this reaction is also called as neutralization reaction. Right. Now the ethanoic acid also reacts with sodium carbonate and it also reacts with sodium hydrogen carbonate. Sodium hydrogen carbonate is also called as the sodium bicarbonate also. So whenever they react with the ethanoic acid, they always form carbon dioxide gas and H2O. So this is a reaction with sodium carbonate. Here CH3COOH plus sodium carbonate Na2CO3. So what will happen? This H will come out and this side will become negative. So Na, which is a positive ion, it will give it will go and attach with CO minus, and it will form sodium ethanoate. Again, if you cannot remember the name, you can simply write sodium salt. Otherwise, in the case of the ethanoic acid, all the salts you can show or you can write as sodium ethanoate. Like here in this case also the sodium ethanoate is getting formed, here also the sodium ethanoate is getting formed. So it is very easy to remember. Now this CO3, which is here, from here CO2 will come out, and the H2O, the one O which is left here, it will combine with H2 and it will form H2O, that is water. Same products will be obtained when ethanoic acid will react with sodium hydrogen carbonate, which is in our next slide. The reaction is shown here. So again, what will happen when ethanoic acid will mix with sodium bicarbonate, which is also called as sodium hydrogen carbonate. Sodium hydrogen carbonate. So this H will come out and this Na will attach with it here. So it will form CH3CO, NaCO2 plus H2O. Now this test is also used, like the reaction of ethanoic acid with the sodium carbonate or with the bicarbonate is also used as one of its testing. Okay, so what is done, that this carbon dioxide gas which is evolved, it is passed through the lime water. So what is done, that suppose this is a test tube here, from the test tube, suppose in this test tube there is ethanoic acid, there is ethanoic acid, and if to this ethanoic acid you are going to add Na2CO3 or NaHCO3, there will be a brisk effervescence with the evolution of gas. Now we will put a cork here, and you can attach a passing tube. This passing tube enters in another test tube which is having the lime water in it. Okay, so the lime water is CaOH whole twice. So what will happen? The incoming gas, the gas which is coming here, if it makes the lime water milky, then it is a test that carbon dioxide gas is evolved, or this incoming gas is carbon dioxide. So this reaction is also used as one of the testings for the presence of the ethanoic acid, basically, that ethanoic acid can be made to react with sodium hydrogen carbonate, or it can be reacted with sodium carbonate. Now let us go to one of the very important part of it, that is esterification. Now by this time you have understood ethanol and ethanoic acid. Okay, now whenever the carboxylic acid, basically we are talking about the ethanoic acid, reacts with alcohol, it forms ester, a very important compound. It is a very important industrial compound. Basically, esters are sweet smelling compound, so they are used in the perfume industries, and they are also used as the flavoring agents. So basically, when ethanoic acid, okay, is warmed with ethanol, when they both are mixed, ethanoic acid and ethanol are mixed in presence of a few drops of concentrated sulfuric acid, okay, which act as a catalyst, and ester, that is, its chemical name is ethyl ethanoate or ethyl acetate, and water are formed. So when ethanoic acid is mixed with ethanol, that is in the presence of the concentrated sulfuric acid, and it is heated little bit, then what happens that after some time ethyl ethanoate, which is called as ester. In exam you can simply write ester. There is no need to write necessarily ethyl ethanoate. If you cannot remember the name, you can simply write ester, and water is formed. So again you are seeing, like if you remember the dehydration reaction of the ethanol, where ethanol is mixed with the H2SO4 and water is removed, the same thing the concentrated H2SO4 is doing here also. When concentrated H2SO4 is added to a solution of ethanoic acid and ethanol, it is removing water. So again you can see that concentrated H2SO4 acts as a very good dehydrating agent. Okay, so what happens here, that the water molecule comes out, that is, you can say here that this H comes out and this OH from CH3COH comes out and it forms water. And what is left? CH3C double bond O. It is here CH3C double bond O. This O is here. So you will have to copy this O simply and then you can write CH2CH3. So this is the ester. So esters are a very sweet smelling compound or the substance, and they are widely used in the perfume industry and as a flavoring agent also. Now this is also like the ester reaction can be done in the lab very easily. In a test tube you can take equal amount of the ethanoic acid and the ethanol. Okay, so you will have to take equal amount of ethanoic acid with ethanol, and in this you can add few drops of concentrated H2SO4 and heat it. Okay, or you can put it in a water bath. Water bath is what it is, a bowl kind of thing which can be kept over a wire mesh. It is having water in it. Okay, and after some time you will see that it will you can heat it for at least 2 minutes, and after that if you will pour this content in 20 to 30 ml of water and smell it, you will get the fruity smell, and this indicates that yes, the ester is formed in this reaction. Now another very important part is saponification reaction. So ester react in the presence of an acid or base to give back the alcohol and the carboxylic acid. Okay, now see, this is the ester formula which is formed in our last reaction in the esterification. Okay, so when it is mixed with NaOH, which is a base, and it is heated, you get sodium salt. This is what? This is sodium salt. And you get ethanol here. If you heat it with water further and you add dilute H2SO4, you will get both. This is ethanoic acid and this is ethanol. So you are getting back both the reactants which were involved in the esterification. Now why this reaction is called as saponification? Because in the first step where the sodium salt is formed, this is a basic formula of soap. This is the basic formula of soap. Now in the formula of the soap, or this is one of a basic reaction that how the soaps are formed. This part remains the same, only here the number of the carbon changes. The carbon chain gets very long. It can have carbon up to 17 or 18 even, or more than that. Okay, so this is the basic formula or the basis of making a soap, and that is why it is called as a saponification. But if this reaction is carried further, okay, that is in the presence of the acid or base, you can get back the ethanoic acid and the ethanol, which are the reagents or the reactant in the formation of the ester. So saponification is also called as the reverse. It is also called as reverse of esterification in lot many ways. It is also called as hydrolysis also, hydrolysis of ester. That is also another very popular term for it. So this brings us to the next topic, that is the soap and detergents. So this topic we are going to cover in our next session about the soaps and the detergent. If you have liked my session, please share its link among your friends and family, and your suggestions are always welcome. Thank you. Bye-bye.